I think most of you probably know what the OPTIMADE Python tools repository actually is by now, but for people who don't, I'm just going to go through some of the overview of the features and kind of the aims of what we've done in this project. And all throughout this talk, feel free to just sort of have the GitHub open and be referring to things. So just to sort of briefly talk about who's actually involved in the project and show that it's sort of not particularly centralized to one database. So I think it's probably fair to say the most active people on it at the moment are Casper, Shyam, myself, and Adam. But we've certainly had a lot of other people in the past. So Abby and Marcus, who are both here, have contributed a lot for the Elasticsearch and Django transformers. Snehal and Fauzi at the last workshop. Tom Purcell, who's also here, and Leo contributed a lot to the models last year. And Donnie, so again, he's not here, but he sort of really set up most of the design of this project, so he deserves some credit. And then, so there's someone called Michael Wu in the GitHub contributors who I've never met. So this really shows that it's a proper open source project and that we have no idea who this person is, or at least I don't, but they've definitely done something good. And as a spinning OPTIMADE logo for you, that was when I was getting bored trying to write this earlier. But really what the project actually is, so it's kind of spiraled out of control a little bit. And I think we've done quite well in reining it in recently and making it much more modular. But essentially it comes down to sort of four main thrusts. The first is this extensible reference server implementation using MongoDB as a backend. And importantly, this implements both the regular and the index metadatabases. This is all built on top of type-hinted Python models. So using the Pydantic library to sort of very succinctly explain or describe the actual human readable specification and turn that into in this case, an open API schema. We have a LARC format description of the filter language and some associated parser, or an associated parser with that. Again, a lot of that was contributed by Adam last year. And we sort of have the tools to turn that into a Mongo query. And then also, as I say, people have contributed Elasticsearch and LARC, and Django formulations of that too. And also we have this implementation validator. So this is essentially just, again, using these same Pydantic models, but running on a remote OPTIMADE implementation, making sure everything can be validated according to the specification. And we also have a GitHub action associated with that that lets you run it as part of your own CI on your server. So you can sort of use any one of those individually. So for example, in my case, I'll use all four of those as kind of a ground up OPTIMADE Python tools implementation. And I think other people sort of pick and choose the bits they actually need. And I guess as a disclaimer, we're pretty close to 1.0 spec compliance, but the actual underlying OPTIMADE Python tools API is probably going to, hopefully is going to change quite a lot over, hopefully over the coming week, but certainly over the coming months, as we sort of iron out some final details on how things should work. And obviously it would be great to have as many people contributing and implementing this and giving us feedback on this, which I guess is the aim of sort of why I'm giving this talk. So who is it actually for, or what is it for? So I think there's things that are useful for people who are writing new implementations from scratch, for sure. But also people who have existing implementations who just want to serve the index metadatabase, which we've seen as sort of a hotly discussed thing today. There's a very easy way just to sort of spin up a Docker image or Docker container, sorry, that will run the index database server and use the sort of latest providers list for that. I think it's also useful for specification development generally. I think now we have this package in place. If we sort of come up with some new ideas this week, we can very quickly prototype them in OPTIMADE Python tools and soon find out sort of what actually is feasible. It's quite a low bar, I guess, because it's the simplest case of a MongoDB that already kind of complies to the specification. So it's not going to sort of catch all potential issues. But I think certainly we can use that to quickly iterate on things. And as I said, also just validating existing implementations. So it's very easy just to sort of point at a remote server and check if everything's working properly. And in terms of who's actually using it, so there are 3, I think, active implementations directly using OPTIMADE Python tools. So Materials Cloud, Materials Project, my own ODBX. And I'm not entirely sure, but I think Nomad and OKMD, at least they might still be using the code that they contributed back to OPTIMADE Python tools. So I'm not sure if we can count that as sort of a native implementation, but certainly there's a lot of databases involved in this actual project. So it's quite well supported in that sense. So yeah, I employ you to explore the GitHub, and very recently our formatted documentation is up, thanks to Cheyenne. So this will be being populated this week. At the moment, it's basically just our README, but also, if I can remember where it is, that will work at some point, a changelog showing what's happening in each PR. But we also have this sort of full model documentation corresponding to, let's find something interesting. I'm looking for structure, obviously, because that's what it's all about. Let's just pick reference. So this is basically giving you the specification, but in a convoluted way that it's been converted to an open API, or it's been converted to a Python model, which is then converted to an open API spec, which is then converted back to this rich text, HTML, and hopefully it sort of preserves the actual meaning of the specification. I think it does, that you can actually see what the models underneath are implementing. And if I'm assuming everyone's familiar with GitHub. I mean, if that's not the case, obviously, feel free to ask any of us. But sort of, you can tell it's a good repository because we've got as many badges as we can fit in the README. So we're definitely got all the sort of best practices boxes ticked there. As I say, certainly this is going to be updated throughout the week as we tweak sort of instructions and usability. But if you spot any issues there, please let us know if you're trying to use it. Okay. So I thought I'd quickly just talk about some of the terminology, just in case people who are involved in the spec heavily but haven't been involved in Python tools. So we often talk about a lot of these things referring to the Python tools, which maybe doesn't make any sense to you. So just to talk through what happens when you actually ping an OPTIMADE Python tools server with a query. We often talk about this blue section as a versioned base URL. The red structures is the particular endpoint we're hitting. And then you have the actual filter parameters. I can use a pen here actually. The filter parameters or the query parameters, which give you the filter, and then things like page limits and sorting. So this goes to our web server, which is currently Unicorn or Goonicorn. You can use either one. And there's some sort of fast API magic going on in the background where we route to a particular endpoint. And then we have an underlying class called entry collection. So this is quite generic. The default server obviously inherits from this and makes a Mongo collection class. So if you were using a completely different backend, you would have to re-implement this class. But you could probably still use our filter parser. So this is going to take the green section of the URL at the top and convert it or pass it through the LARC grammar and actually sort of parse what's going on. We then have a filter transformer down here. So this takes us from the sort of abstract LARC grammar to a direct Mongo, in this case, MongoDB query. And as I say, we have stuff implemented for Elastic and Django as well. So you'd have to re-implement this as well if you had a different backend. And this itself communicates with what we call an entry mapper, which is useful for just things like changing field names if you have a simple alias between fields and the OPTIMADE specification. Of course, this query then gets passed to the actual underlying database, which could be Mongo or whatever you want. You do have to bring that bit yourself, obviously. And the results from this get passed out to the entry collection and serialized in our Pydantic models. So generically, we have an entry resource, so something with an ID and something with attributes. You would then define the entry resource attributes particularly. So for example, in my case, I've inherited from structure resource attributes with like an ODBX structure resource attributes. And this is where you can add things like extra provider fields. And essentially the server will handle adding all the implementation specific prefixes and things to this. And then perhaps sort of an overlooked part of the value of the OPTIMADE Python tools is that we have models for the actual response. So I think this is quite a tricky part to actually get right if you were just reading the specification. So I don't want to say it's impossible, but I think it's difficult to return an incorrect response if you're using our models, because we've kind of already handled all the sort of, not quirks, but all the sort of edge cases in the specification in a sane way. So I guess to summarize, the orange blocks are the things you will almost certainly have to re-implement if you were using OPTIMADE Python tools on a generic database. And certainly if you're using a different backend to Mongo, then the filter transformer also needs to be changed. But everything else should be fairly reusable. And there's quite a lot of machinery going on there just on its own. Okay, I've kind of just said some of this, but if you're creating a new implementation, unless you've got a very simple map between your underlying database and OPTIMADE, you're probably going to have to do some actual Python coding. But we do have a way just to configure a lot of things without any Python. So I can provide a demo of that later on if people are interested. But I think that's going to be a bit more specific if anyone's actually coming up with an implementation this week. And yeah, if you're using MongoDB, hopefully you can use our transformers, provided your data again has a similar structure. But otherwise, you can certainly just inherit from what we already have and tweak it as you want. And one sort of particular drawback I should bring up is that if you have a simple alias field, or sorry, if you have not a simple alias field, if you have a field that you can populate in the response in a simple way, then that doesn't necessarily mean that that field is going to be queryable. So we don't have any way of sort of pushing new fields back to your database, which is almost certainly a good thing. So there is still some overhead of having to make sure that you at least have some fields that you can query that would give you what the OPTIMADE specification would expect from the field in the OPTIMADE specification, if that makes sense. So for example, if you don't have a chemical formula anonymous field in your database, there's no way you can query that to mimic sort of a black box OPTIMADE specification. So you would need to populate that in your database yourself. We don't sort of have any tools for doing that at the moment. So yeah, generally the advantages of using this package, I think it can be used to very quickly prototype things. We support quite a lot of extra features like the provider field and some more that I'll talk about in a minute. We handle quite a lot of the quirks of filtering and responses for you automatically. And I think, yeah, the changes to the spec are sort of pretty quickly implemented. But I mean, I say that we still haven't quite got to 1.0 yet, but then I guess neither has the spec. And we've made sure it's definitely quite modular, so you just use the bits you need. If you do a standard pip install OPTIMADE, you only get the sort of the core models, and that is really sort of the purpose of it. If you wanted to actually run a server yourself, then you can pip install with these sort of server extra requirements, as described in our installation instructions. I've already mentioned some of these drawbacks. So we can map responses easily, but it's difficult to map queries. So that can require quite a lot of extra work at the database end. If you're using a new backend entirely, then so you basically you're on your own. You have to do it yourself. Although I think, so for example, I know Casper has implemented stuff for AIDA. So it depends on what your query model is underneath, but it's not out of the question to still use some of these tools. And generally scalability. So something Shai mentioned yesterday about whether sort of all these sort of small implementations that this could enable can actually handle the load of, well, certainly can't handle the load of materials projects, Nomad and COD. And that's something to think about when you're using this server and sort of putting it out there. But I guess, as I said, materials project are using this at the moment for their fields. So hopefully any changes they make in terms of scalability and best practices there can sort of filter down to the community as well. Okay, so then this is kind of moving more onto the demo stuff. So this is talking about the models we actually have, the LARC grammar, and one particular aspect of length aliases that I thought I should just quickly mention. So one thing we do in the Mongo transformer is if you're querying for length on a property, you can define a length alias so that the query is transformed from length of some complicated thing to just the size of some other integer. And we weren't sure if maybe this is something that could be suggested back in the specification. So I think at the moment you can have a property that can't have length qualified on it if it's if you have a list quantity, you have to be able to query its length. This could be one way around that if you have some sort of very complicated thing. So that's already in there. And then just generally, our plans for this workshop, as I've already said, we're gonna be improving the documentation for sure, which was started last night. It'd be great to get some feedback and sort of figure out where maybe this doesn't match perfectly with other implementations. We've got some open issues. Feel free to have a look at those. We actually have a project board for the workshop specifically of things we're going to be tackling. And a lot of this discussion will hopefully be happening in room 4. If you want to actually contribute this week, make sure you're part of the Materials Consortia GitHub organization. So I think everyone on that is an admin, so no one has an excuse to not let you in. It should be very easy. And please sort of feel free to raise issues to discuss if you want to plan to do something, or if you see an issue you want to tackle, please just comment on it and say you're going to work on it, so we're not sort of duplicating efforts. And I think from the last 10 minutes or 20 minutes, I was asked to say that if you should please push to a feature branch in the main repository and make a pull request that way, rather than sort of proliferating lots of different forks, so that we can actually also help out with your implementations. This was maybe where Casper could jump in and talk about his clients.
Yeah, so I can just plug my client here for a second. So I developed this in Jupyter on the basis of OPTIMADE Python tools in terms of the models, at least, that it's using. And I've since contributed also an adapter back to the Python tools, where it's basically a wrapper for the entry resources to convert to different libraries, so ASE, PyMatGen structures, and so on, which is really useful for downloading. So for example, here I would then go to Materials Cloud and choose myself a database. Here, the curated equivalent organic frameworks database by Leopold. And then there's some simple filtering. You can also do a raw query. But what's nice is that I tried to do some dynamic updating here. So this database has only structures with 2 to 7 elements in them, whereas if I choose another one, it will update to another one. And then you can basically just adapt that and query and get some nice structures. That's a huge, yeah. So that's a weird structure. Let's see if we can find a nicer one. So that looks nice. You can see the void space in the cuff. And then, so here we're extending it to use the converters already implemented in ASE. So basically, we're just converting to an ASE atoms from the so the data structure of the OPTIMADE structure resource, converting that into an ASE atoms, and then we can download that as an XYZ format or whatever we really want. And there's also implementation for PyMatGen, but at the moment it's very, I mean, it's to the same format, so there's a lot of things there. I'm considering making an extra drop down so you can choose the transformer you want. And then there's a list of sites, so some introspection on the specific structure. Also coming is an elements chooser, so a periodic table basically, where you can pick and choose and explicitly include or exclude elements. And of course, if you then choose a database which only has one database, then that's the result. So here you will get Matthew's lithium tin structures. All right. Yeah, so I wanted to talk a bit about the validator as well, but it's more just saying that if you want to contribute, the validator is a very good place to start if you really want to take something on. So it's Matthew who basically started this, but it's very nice. The issue is it's very monolithic at the moment, and so there's no way to test just a single endpoints. Say I just have a database with just the structures endpoints or nothing, then I can't run this for the full validation of that endpoint, or will fail rather. But what's nice is that then this GitHub action uses the validator, and so we use this internally in the OPTIMADE Python tools as well to basically check that the spec that we're producing and the server that we're producing at the end is a valid OPTIMADE server. So that you can use. That's it.